Hello, and welcome to the Chemistry 1412 mini-lecture on KSP. KSP is the equilibrium constant of reactions in which a solid is in equilibrium with its aqueous ions. The SP stands for solubility product. KSP is used in industrial processes such as the desalination of ocean water, the making of soap, and the purification of table salt. Here we see an example of the equilibrium of bismuth sulfide with the two ions in it. Notice that the reactant of KSP will always be a solid. Therefore, the equilibrium expression of the KSP reactions will never have a denominator. Also take note that the coefficients in the balanced equation are 2 and 3 in this reaction. These will be important when we do the Rice table for this equilibrium. Here is the Rice table for the reaction shown. You do not know how much of the solid will dissolve, so you call the amount of ion created X. Please note that the coefficient in the balanced reaction becomes the coefficient of X in the table. This means that not only will the concentrations be squared or cubed in the equilibrium expression, their values will also often be 2x or 3x. When you plug them into the equilibrium expression, as in this example, you will have a term which equals 108x to the fifth. Remember to square or cube both the number and the x when solving for x. X is called the molar solubility. Now let us consider an equilibrium of a solid with its ions, only now we are adding one of the ions to the solution which is common to the solid. When you add a product to an equilibrium, Le Chatelier's principle tells us that the equilibrium will shift backwards towards reactants. This means that more solid is created and the ions concentrations will go down. In other words, adding a common ion decreases the solubility of a solid. We call this phenomenon the common ion effect. Thank you for viewing the mini lecture for solubility product from our Chemistry 1412 class with Dr. Elizabeth Bell. Please go to Sapling and finish the associated assignments at this time. Remember, you can contact me at any time with questions. I am happy to help.